طالبات الثانوية العامة القسم العلمي رياضيات لغات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج ديناميكس. النهاردة إن شاء الله هنستعرض موضوع من أهم موضوعات الديناميكس وهو موضوع the Mometum. Dear student of grade 3 secondary, welcome to our math program. Today we have dynamics. Our lesson today is the Mometum. The first unit, 1 ton, which equals 1000 kilogram, and 1 kilogram equals 1000 gram, and 1 gram equals 1000 milligram. Now, what is the momentum? Definition: the momentum vector of a particle at a certain instant is defined as the product of the mass of the particle and its velocity vector at this instant. Then h equals mv. Vector h, the vector of momentum, equals m, the mass, times the velocity vector v. And the algebraic measure of the momentum is equal to the product of the mass times the algebraic measure of its velocity vector. Then h, the momentum, h equals m, the mass, times the velocity. What is the unit of measure of the magnitude of momentum? The momentum h equals m times v. Then unit of measure of h equals mass unit times velocity unit. For example, gram times centimeter per second, gram mass unit, and centimeter per second velocity unit. Or kilogram times meter per second, kilogram is the unit of mass, and meter per second is the velocity unit. And we can use kilogram times meter per hour. Kilogram mass unit and kilometer per hour is the velocity unit. Let's start with the first example. Calculate the momentum of a train whose mass is 40 tons moving towards the north with a uniform speed of magnitude 72 kilometers per hour. We have the mass equal 40 tons and the velocity equals 72 kilometers per hour. And we know that h equals mv. h, the momentum, equals 40 times 72. 40 is the mass and 72 is the velocity. Then 40 times 72 equals 2880 tons times kilometer per hour. Now we use the algebraic measure of the velocity and the momentum. Another example: a car of mass 2 tons moves in a straight line such that x, which is the position vector, equals 3t power 2 minus 4t plus 1 in the direction of e, where e is the unit vector in the direction of the motion of the car. If x is measured in meter, find the magnitude of the momentum of the car when it starts to move, then after 3 seconds of its motion. Now we have the position vector x equals 3t power 2 minus 4t plus 1 e, where e is the unit vector in the direction of the motion of the car. And we know that the velocity v equals the derivative of the position vector x with respect to time. v equals derivative of x with respect to t. Then v equals the derivative of 3t power 2 is 6t minus the derivative of 4t is negative 4 and the derivative of 1 is 0, which is a constant. Then the velocity vector equals 6t minus 4e. At the beginning of the motion, the time t equals 0. Then the velocity vector v equals 6 times 0 minus 4, which equals negative 4e. Since h equals mv, h is the symbol of momentum, equals m, the mass, times v, which is the velocity. The vector h equals 2000 times negative 4e. The vector h equals negative 8000e. Now we have the vector velocity, the vector momentum. Then the magnitude of momentum equals 8000 kilogram times meter per second. Kilogram is the mass of the body, of the car. The mass of the car 2 tons. We multiply it by 1000. We have 2000 kilogram times the velocity, which is 2 negative 4e. Then the momentum equals negative 8000e. But the magnitude of the momentum equals 8000 kilogram times meter per second. The second required when t equal 3 seconds, after 3 seconds of its motion. Then the velocity vector v equals 6 times 3 minus 4e. Then the velocity vector v equals 14e. Then h equals mv. The vector h equals the mass times the vector velocity. Then h equals, vector h equals 2000 times 14e. Then the momentum vector equals 28,000e. But we find the magnitude of the momentum. The magnitude of momentum equals 28,000 kilogram meter per second. Now we study the change in momentum. The change in momentum equals momentum vector h2 minus momentum vector h1, which equals m v2 vector minus m v1 vector. Now we can take m as a common factor. Then h2 vector minus h1 vectors equals m multiply between two brackets vector v2 minus vector v1. Then delta h, delta is the symbol of the change in momentum. Delta h vector equals m times delta v vector, or delta h vector equals m between two brackets vector v2 minus vector v1. Then delta h equals the mass of the body multiplying the change in its velocity. We have a vectors v2 minus v1, and we must note that determine the sign of the algebraic measure of each velocity before and after the change. And the magnitude of the change in momentum equals norm vector h2 minus vector h1. Now we move to the next example. A rubber ball of mass 200 grams is let to fall on a horizontal surface from a height of 90 centimeter to rebounded up to height of 40 centimeter. Calculate using kilogram meter per second unit the magnitude of the change of momentum of the ball as a result of impact. First, we let C be the unit vector directed vertically upwards and studying the motion of the ball in case of falling. The velocity v power 2 equals v naught power 2 plus 2 gs. Then v squared equals 0, 0 is the initial velocity, plus 2 times 980, which is G, times S, which is 90 centimeter. Then the velocity equals 420 centimeter per second. Now we can use the vector velocity V1 equals 420 c. Now we're studying the motion of the ball in case of rebounding. Since V power 2 equals V naught power 2 plus 2GS, then the terminal velocity equals 0. 0 equals V naught power 2 minus 2 times 980 times 40. Then the initial velocity V naught equals 280 centimeter per second. And we can use the vector velocity V2 equals negative 280 c. Now, the change in momentum, delta H vector, equals the mass of the body, the mass of the ball, times vector V2 minus vector V1. Then, delta H equals 200 over 1000 multiply negative 2.8 minus 4.2 c. Note that the mass of the ball is 200 gram and we convert it to kilogram because the example say calculate using kilogram meter per second unit the magnitude of the change of momentum. Then we change the mass of the body from gram to kilogram. Then delta H equals negative 1.4 c. Then the magnitude of the change in momentum equals the norm of the vector delta H. Norm of vector negative 1.4 c equals 1.4 kilogram times meter per second. Now we can, using integration, to find delta H. If A function in time t, A is the acceleration of the moving body, then delta H equals m multiplying V2 minus V1. Delta H vector equals m between two brackets velocity vector V2 minus the velocity vector V1. And we know that integration dV from V1 to V2 equals integration A dt from T1 T2. Then delta H equals m integration A dt from T1 to T2. Now we move to the next example. A body moves in a straight line such that the acceleration of its motion A is given as a function of time t by the relation A equals 2t minus 6, where A is measured in meter per second square unit and time t in second. Calculate the momentum of the body in the time interval 3 smaller than or equals t smaller than or equals 5 if the mass of the body is 8 kilogram. Now we know that delta H equals the mass of the body m times integration A dt from T1 to T2. Then delta H equals 8 times integration 2t minus 6 dt from 3 to 5. Then delta H equals 8 multiply. The integration of 2t equals 2t power 2 over 2. We can simplify 2 and 2 from the numerator and denominator. Then the integration of 2t is t power 2 minus the integration of 6 is equal to 6t. The definite integration from 3 to 5. Now we can substitute about 5 and 3 in the relation by using the definite integral. Then delta H equals 8 between two brackets 5 power 2 minus 6 times 5 minus 3 power 2 minus 6 times 3. Then delta H equals 32 kilogram meter per second, and the vector of change in momentum delta vector h equal 32c vector, where c is the unit vector in the direction of the motion of the body. Now we move to the next example. A car of mass 1.5 tons moves in a straight line such that the acceleration E, function in time t, is given by the relation A equals 12t minus t power 2, where the acceleration A is measured in meter per second square unit and the time t measured in second. Find, number 1, the change of momentum of the car during the first 6 seconds. Number 2, the change of momentum of the car during the time interval, closed interval 2 and 14. We know that delta H equals m times integration the acceleration A with respect to the time t from t1 to t2. Then delta H equals 1500, the mass of the body, or 1.5 tons, times integration 12t minus t power 2 from 0 to 6. Delta H equals 1.5. The integration of 12t is 6t power 2. We add 1 to the power and divided by the new power. Then 12t power 2 over 2 equals 6t power 2. Minus the integration of t power 2 is t power 3 over 3, or third t power 3. The definite integration from 0 to 6. Then delta H equals the mass 1.5 multiply 6 times 6 power 2 minus third times 6 power 3, minus 6 power times 0 power 2 minus third times 0 power 3. Then delta H equals 216 tons meter per second. Now the second required the change of momentum of the car during the time interval 2 to 14. Now delta H equals m integration A dt from t1 to t2. Then delta H equals the mass of the car 1.5 times integration the acceleration function 12t minus t power 2 with respect to time t from 2 to 14. Then delta H equals 1.5 6t power 2 minus third t power 3 from 2 to 14. 6t power 2 is the integration of 12t, and third t power 3 is the integration of t power 2. By using the definite integration, then delta H equals 1.5 multiply 6 times 14 power 2 minus third times 14 power 3 minus 6 times 2 power 2 minus third times 2 power 3. Then delta H equals 360 tons meter per second. Another example. A falling raindrop is of mass 0.4 gram at a certain instant. If vapor accumulates on its surface during its fall at the constant rate 5 milligram per second, then the mass of the raindrop after 2 minutes from this instant equals what? Gram. 0.4, 0.6, 1, or 2 gram. Now, the rate of change of the mass is constant. Then m equals m naught plus dm dt times t. The mass of the raindrop, m equals the initial mass 0.4 plus the rate, which is 5 milligram per second, but we divide it by 1000 to convert it to gram, times the time 2 minutes, which is 120 seconds. Then the mass equals 1 gram. Then these questions, we have 4 multiple choices. Then we choose the answer C. Then the mass of the raindrop after 2 minutes from the instant equals 1 gram. Another example. A particle moves in a straight line such that the algebraic measure of its velocity v is given as a function in time t with the relation v equals 6t power 2 minus 24, where v is measured in meter per second. Find the magnitude of the acceleration of the particle when its velocity becomes 30 meter per second. The second required, find the magnitude of the displacement during the time interval t belongs to the closed interval 1 to 4. The first required, since the velocity v equal 6t power 2 minus 24, then the acceleration equals dv dt. The derivative of velocity with respect to time equals 12t minus 0. Then the derivative of 6t power 2 minus 24 equals 12t. Now we have the acceleration in terms of t. When the velocity equals 30 meter per second, then 6t power 2 minus 24 equals 30. We adding 24 to both sides, then t power 2 equals 54 divided by 6, then t power 2 equals 9. Then the time equals 3 seconds. The acceleration at this instant, a equals 12 times t, 12 times 3 equals 36 meter per second squared. And the second required, since the velocity v equals 6t power 2 minus 24, and we know that the velocity is dx dt, then dx dt equals 6t power 2 minus 24. Now the integration of dx from x naught to x equals integration of 6t power 2 minus 24 dt from 1 to 4. The integration of dx is x from x naught to x, and the integration of 6t power 2 is 6t power 3 over 3, which is 2t power 3, and the integration of negative 24 is negative 24t. The definite integral from 1 to 4, then x minus x naught equals, we can substituting about 4 and 1 by using the definite integral, then 2 times 4 power 3 minus 24 times 4 minus 2 times 1 power 3 minus 24 times 1, then the displacement S equals 54 meter. In this example, we use the derivative and the integration in the two required of this example. بكده أعزائي نكون استعرضنا مع بعض موضوع المومنتم، وعرفنا ايه هو المومنتم، وعرفنا اليونتس اللي بستخدمها مع المومنتم. عرفنا ان المومنتم H equals M times V. عرفنا اليونتس بتاعت الام اللي هي الماس، كمان اليونتس بتاعت الفيلوسيتي اللي هي ممكن تكون كيلو جرام تايمز متر بير سكند، او جرام تايمز سنتيمتر بير سكند، او حتى طن تايمز كيلو متر بير اور. استعرضنا مع بعض كمان موضوع change in momentum، وعرفنا ان المومنتم ممكن يتغير حسب ما الفيلوسيتي بتاعته بتتغير. يعني لو في بادي بيتحرك وغير الفيلوسيتي بتاعته، فاكيد المومنتم كمان هيتغير. نقدر نحسب المومنتم في الفيرست كيس والسكند كيس، ونقدر نجيب الدلتا اتش اللي هو التشينج ان مومنتم بالرول او بالريليشن ام V2 minus V1. كمان عرفنا ان ممكن ادخل موضوع الانتجريشن في حساب التشينج في المومنتم، وعرفنا ان ممكن اعرف الفانكشن بتاعتي تكون تايم الانترفال بتاعتنا in terms of t. كمان عرفنا ان ممكن تكون الريليشن in terms of t، يعني التايم هو اللي مأثر معايا في الموضوع، وشفنا الديسبليسمنت وشفنا البوزيشن فيكتور وشفنا الفيلوسيتي فيكتور وشفنا الاكسلريشن، وعرفنا ازاي نتنقل من الديسبليسمنت للفيلوسيتي عن طريق الديريفيتيف، ومن الفيلوسيتي للاكسلريشن عن طريق الديريفيتيف، وعرفنا نرجع كمان من الاكسلريشن للفيلوسيتي عن طريق الانتجريشن، ومن الفيلوسيتي للديسبليسمنت او للبوزيشن فيكتور عن طريق الانتجريشن. استخدمنا الديفينيت انتجرال واستخدمنا الرولز اللي اتعلمناها في الانتجريشن عشان نقدر نحسب change in momentum. And by this example we come to the end of our program today, and till we meet again, it's goodbye.